So now that we've done a lot of practice with derivatives, we're going to go back and revisit limits briefly, because there's a few limits that are really, really hard to do, but we can actually use derivatives with them to make them easier. And there's a few limits that are impossible to do without derivatives. So I'll show you some of those examples today. And we're going to be using what's called L'Hopital's rule. Please don't pronounce that S in here, by the way. You'll also see this written as L'Hopital with a little circumflex over the O. So that is the French word for hospital, and it also is the name of a French mathematician, L'Hopital. First, I'd like to mention the term indeterminate form. So if you're evaluating a limit, and when you plug in your limit value and you get a 0 over 0 or you get an infinity over infinity, we call that an indeterminate form. So for example, let's say we have the limit of ln of x over x minus 1 as x approaches 1. If you evaluate the limit of the numerator and the limit of the denominator, you actually will get 0 for each of those. So we are going to, I'll show you what we're going to do, and I'm going to explain why I'm writing it like this in just a second. So if you evaluate ln of 1, you get 0. If you evaluate x minus 1, you get 0 when you plug in x. So we say this is of the indeterminate form 0 over 0. Now, most people would say, well, why don't I just write it like this, 0 over 0? Sorry, that's really hard to see. I'll write it in black. So if you write it like that, you're technically writing something that is impossible in math. 0 over 0 is not a mathematical expression. First of all, you can't divide by 0, but 0 over 0 is just, we say it's indeterminate, so you can't actually write that. Now, you can write something like what I wrote here. It's long, I know, or you can write out, this limit gives us the indeterminate form 0 over 0, also not pleasant. I think writing it the way that I just wrote it here, where you do the limit of the top, limit of the bottom, is sufficient. But either way, I do want you to know that if you get a 0 over 0, that is a sign that you often can do more work. Occasionally, you will find something that you can factor. We did those early on in the year, and you get a 0 over 0. But if it's easier for you, you can also use L'Hopital's rule. So I'll give you the rule right now. So here's L'Hopital's rule right here. So if you get an indeterminate form, then what you can do is you can take the derivative of the top of the fraction and the derivative of the bottom of the fraction, and then you can evaluate that limit. So let's do a few examples. So for number 1, I'm just going to give you the one that I already showed you. If you evaluate this, if you do ln of 1 over 1 minus 1, you will find that you get 0 over 0. So like I said before, if you write that on your AP exam, that's actually not a true mathematical statement because 0 over 0 is impossible. You're welcome, though, to write that and then cross it out, because the little trick with the AP exam is that whatever you cross out does not get graded. So what I'm going to do is I am going to, now that I've determined that it's indeterminate, I am going to take the derivative of my numerator, and I'm going to take the derivative of my denominator. So derivative of my numerator is 1 over x. Derivative of my denominator is 1. I end up getting the limit as x approaches 1 of 1 over x. Now I can plug in that 1 for x, and I just end up getting that my answer is 1. So that's all you really do. I do want to warn you, please do not try to use the quotient rule when you get something like this. The quotient rule is terrible and long for this one, and you will get the wrong answer. That's the worst part about it after doing all that work. So remember that you're going to take the derivative of the numerator and the derivative of the denominator separately. So here's another problem You might remember doing stuff like this previously. We rationalized on these ones, but actually you are allowed to use L'Hopital's rule on this. So I want you to look at it. First thing you always want to do when you have a limit is check to see what happens when you substitute in a value. So if I substitute in 4 for that one, I will get 0 over 0. So now I can go ahead and use L'Hopital's rule. And keeping in mind that this is x to the 1/2, not perfect, not completely easy, but it's easier, in my opinion, than rationalizing. So if I take the derivative of my numerator, I get 1/2 x to the negative 1/2 over 1. So now that's going to give me limit as x approaches 4 of 1 over 2 radical x. And if I plug in 4 for that, I just get 1/4. So in my opinion, these types of problems are now a lot faster. The ones that are really, really fast are the ones that involve factoring. They go pretty quickly with L'Hopital's rules. So keep in mind that you can use this for any type of situation as long as you get an indeterminate form. So here's my second type of problem. So if I have limit as x approaches infinity of 3x over e to the x, if you were to try to substitute in infinity for the x in each of the numerator and denominator, you would get a situation where you have infinity over infinity. So what I'm going to do is I am going to use L'Hopital's rule. So first of all, if I substitute it in, I would get an indeterminate form of infinity over infinity. Remember, you can write that on the side, but you can't write this equals infinity over infinity. That equal sign is enough to make you lose an entire point on an AP free response, so please don't do that. So it's an indeterminate form, but now I can go ahead and use my rule. I end up getting 3 over e to the x, so I still get an infinity in my denominator, but now I have 3 over infinity. So that's going to be equivalent to 3 over infinity. Keep in mind, if you have a really small number over a really big number, that's going to be equivalent to a limit of 0. So here's another type. However, you're going to get the same, it's almost exactly the same as number 3. The only difference is that you're going to plug in infinity. You get an infinity over infinity indeterminate form. So then you're going to go ahead and use L'Hopital's rule, take the derivative. When you take the derivative, you're going to get another infinity over infinity. Now you can actually continue taking the derivative. In fact, you can take the derivative until you actually, until you get something that is not an indeterminate form. So now I just end up getting I get infinity over 2, which just gives me an answer of infinity. I do want to warn you with these, please check and make sure that you get an indeterminate form before using L'Hopital's rule. A lot of students, once they learn L'Hopital's, they want to use it all the time, and you're not going to use it all the time. You only use it if you get a 0 over 0 or an infinity over infinity.